So, you can see my course. This is a course I'm going to present. It's called Imagination, Creativity and Innovation in Science. I suppose I'm an entomologist by trade, infectious disease vectors, that's my thing. So this was a real step into something new for me. I work in the School of Biological Sciences, and we have everything from people who pipette things into tube, I'm talking about the students and the staff, to people who measure trees, in Asia. So we've got a really broad range of students, but not biomedical. So we're sort of on the animal and plant end of it. The reason I made the course was, you all know, I'm sure, most of you, Sir Ken Robinson, and he was a great advocate of, unfortunately, he died recently, he was a great advocate of getting creativity into the curriculum at school level and beyond. And then I got involved with a project with the guy that you can just about see at the back there, beside these lovely costumes, Charlie Hackett at Gray's School of Art in Aberdeen, and he asked me to give a presentation to his art students, fashion students, on insects. And I did that, and they made costumes based on this and other interactions. And then I got my students, which is those are the guys on the right there, the biologists, I got them we had a fashion show, and they wore the costumes, which were insect-based, and we did it in a pub in Aberdeen as part of, I think it was British Science Week. And the student said to me, John, can we do more of this? We really like this, we really like the interaction with the artists, and can we do more? So what I did was, I signed myself up to, this is my first thing I did, so this is my journey to the course. I signed myself up at Gray's School of Art to a ceramics course. It was part-time in the evening, and for those of you who have ever made pots, you'll know that most of them, they either explode in the kiln or they collapse, or you get very little out of it. Anyway, these are what I got out of it. I'm not going to explain what they mean, but I actually they're not very good, is the first thing. That's a glaze that I invented, so I was very pleased with that. And these were up there was an end of term show, so these are up against other proper ceramic students. They're all part-time, but the artisans. And I put my rubbish pots in there, and I wanted to feel what it was like to put something on display like that and be exposed like that. It was something that you just had a quick go at. Anyway, people laughed at them, so that was good. And then I made a rubric. And how do you measure creativity? How do you measure innovation? Well, I made a rubric. In the course, the students have to make products. And it's deliberately vague. They have to make products. The products can be anything, almost anything. And the products were graded on novelty and imagination, observation of the product. Conceptual value, is the product valuable? The product itself, but you have to reference to a definition of the product, and that's the third part of the rubric, 20%. They have to define why the product is what it is and why it is useful. I'll show you some products in a minute to kind of bring this together. And they're also measured on their endeavour and approach. It's quite difficult to do, but I have workshops with the students, and what I didn't want was some students on the course sort of spreading negativity. Because it's very difficult to create, it's very difficult to form products and not be very self-critical of those products. And if negativity feeds in, I didn't want that. So that's kind of, and they're not measured on the actual product itself, like what it looks like. It's the ideas behind the product, and that's really important. I had external examiners come in and had a look around. We do a show at the end of the course. And I put this just to describe to them what we actually did in the course. And I put this up so you don't need to read all that, but the thing to take out of this, it's a 5-week course. They have to make 2 products. One is a team of 2 and one individually. They have to recognise a problem or issue related mainly to the life sciences, but we have a wild card, so they come up with, if they invented something really cool, I would let that pass. And it's going to be novel, and it's really difficult. It's quite easy to check whether they're novel because you can just Google their products and see if there's something similar already done. And then they have 30 timetable hours to make their products. So they've got 2 weeks of workshops and then 3 weeks of creating products. What I did was, I wanted the students to have exposure to people from outside of the School of Biological Sciences. So Hannah is a personal friend of mine. She's a lecturer at SRUC, Scottish Rural College. And she starts them off, and she kind of does this thing called deconstruction and reconstruct. It's trying to get them to think imaginatively. I got Aberdeen FC's artist in residence come in. He taught them how to use digital media. He also works at the university. Jenna is our enterprise advisor. So if the students make a product and they think they want to commercialize it, she can facilitate that. I brought in an artist, Anna, who was at Grade School of Art, and she gets the students to make 3D art installations. I've got a buddy, Ewan. He works in genomics. He's also done some award-winning work on honeybees, etc. And he taught them about creative uses of DNA. Sylvia Cassini, she showed them some weird science videos from way back in the day, sort of getting them to think about science in a different way. Amy Briscoe, she got them to walk around the university doing creative things. And David Lasso, and he was showing them how you can use blockchain in conservation. So the really broad range. Now, these could have been very different categories or different people. All I want the students to do was to think, well, there's really different ways of looking at the world. I also booked rooms that were unusual to the students. So this is an art studio here. This isn't doing a brainstorming session. That's the students there, the brainstorming. That's Mighty in the DNA session. This is the students here creating 3D art, and this is them doing the walk. So they did a lot, the first 2 weeks, they did all these sort of stuff that they would never have done really before. I suppose they might have distracted DNA before, but Ewan was telling them about different ways DNA can be used. And this is a product. This is one of the products, right? It's, now this is to demonstrate several things. One is that the confidence the students had to make something like this. So they rigged this up. So this is an autoerotic asphyxiation safety device. It was well referenced. It had an actual physical tool where you could let go of it and the autoerotic asphyxiation would stop. They suggested a sensor there to monitor blood oxygen levels. I've checked, and this is a big issue. If anybody wants to talk, I'll not go into it now, but it is, and this is a really well-graded product. And I'll show you the students who made it after. You may be surprised. And this is another one of the products. And this was a really successful game to demonstrate microevolution. This is really to show you, the students aren't marked on the beauty of this. They're marked on the concept. But they put so much into it that we were blown away at the end of course show. And of course, the external examiners, they were going in to look at that autoerotic asphyxiation device, and I'm thinking, that's the first year I ran the course. It started in 2019, I'm thinking, oh God, but it was all right. And this is just a few, there's not all of, a whole broad range of products. Once they get encouragement and they start being imaginative and all the rest of it, lots of apps, which are of varying standards, songs, raps, to explain tropical disease, lots of dances, lots of board games, which are of varying success, Instagram sites, kits for improving wildlife, devices to aid people with disabilities, blood alcohol level safety device, wildlife repairing fences, less stress to decompress. That was an interesting one. That was during lockdown last year, and the student was actually in Hawaii, and she lived with some guys, and she worried that every time she went for a poo, it would make a lot of noise, and that she was embarrassed by that. So she made this device that would cover the noise, and you could take it into the toilets and cubicles, and it would cover the noise, and it was like a sort of a, you could wipe the seat down with it and all the rest of it. Anyway, so that was less stress to decompress. It's all biology, right? It's all biology. Kids' books, which, sorry, too many kids' books, but some of them were all right. A new religion we had this year. A naked calendar where students actually, and that was to highlight the plight of rare plants, and the student actually painted some of their friends, and there were naked bodies in the, that's what students do. And lots of energy-saving devices. Did they like it? They loved it. And so I was allowed to grow so much, I'm really grateful. Felt happier, more relaxed, exactly what I needed. My last year, very fun course. I'm capable of being creative. Best course I've done in 4 years. It provided me with an opportunity to explore areas in science, and it challenged me to utilize my knowledge in a different way. intellectually demanding, but in a way that made me strive to achieve more. In my opinion, this course should be compulsory, and this is one from this year. I loved how different and best sense the course was. Even after a full day of teaching, I felt energized, intellectually stimulated, and curious what the next lecture will bring. I liked that the general framework was provided and how to approach creativity based on problem solving, which I can make a good use of at any point in the future. The atmosphere felt really informal, but to be honest, this made the course even more enjoyable. Workshops were really diverse, and each of them provided a bit different point of view on a given problem, which I really appreciated. I also felt I could finally use my whole personality in a university course. And then my favorite one, John should be given a pay rise. So that was great. Negatives, yep. It's a bit short, I think, but that's our term. It should be longer probably, but then, you know, it depends. You know, it forces them to do something quite quickly. Giving the students feedback on their products through the course, if they're not really, if they're not really following the rubric or whatever, it's very difficult. I believe Elon Musk, so a colleague telling me, uses this it's a positive reinforcement. Yeah, okay, that product might not be just there, but if you did this to it, but if you did that to it, but students get fed up with that as well, constantly going over hurdles. Some of them cope with it better than others, but this is not common, and I think I know who this student was, and some of them are very sensitive to any sort of criticism, but it happens. Two students so far have complained about the marks. It's run two years now, so it started just before the pandemic. But that was easily, the rubric works really well. You can measure creativity, you can measure these things. Some students really, even students who do really well at the whole we tell you stuff and you tell us stuff back, some of them really just can't come up with the idea. And it is hard, it's really hard. And some of them go off on a real science fiction. A couple of students last year thought you could measure dreams and actually project the dream onto a screen. I said, well, you can measure the activity, but I don't think you can get a picture. And they were like, really? Yeah, so anyway, they've been watching too many movies. So these are former students. So this guy here, Elliot, and this girl here, they're the ones that are behind the autoerotic asphyxiation safety device. And Elliot has now got, these are current students I brought to his winery. This is a winery. Elliot said that, I've got to say your course put me on an amazing trajectory I could not have expected. So he's got lots of new business ideas and all the rest of it. And he asked Baxter's Soup, have they got any spare fruit that they often throw out? And they give him 3.5 tons of fruit. And this is them being made into wine. The wine is lovely, unexpectedly. Actually, I thought it was going to be horrible. But, so we all bought some wine. Anna Kebke, she now works at the Marine Lab, and she helped set up a food redistribution scheme. So they kind of came alive in a way that maybe, I can't say that the course did everything, of course, but it certainly had an impact here. And they got into the P&J. And final thoughts, thank you very much, to my inspirational former boss, Mary Cutter, Professor Mary Cutter, who was a neuroscientist and taught me how to teach. And Michelle Pinard, who's our director of teaching, and was very supportive. I've come up with this idea, and it seemed a bit wacky, but she was like, no, go for it. So, well received, but students it is high impact. Students need a lot of support. Not all academic staff are supportive. They're really sneery about things like this, but hey-ho. It's really satisfying, and I think in the UK, I think we're better placed than almost anywhere to be creative, and to it's a creative society as far as I'm concerned. Anyway, thank you very much.
So thank you very much to the Royal Society for inviting me along to present. I'm from Imperial College, as this slide says. And my name is Dr Paul Seldon. I did my PhD at Imperial College, and I now work in the graduate school, helping to train PhD researchers. So we're moving from undergraduates to actually PhD researchers in this presentation. Okay, that's that. I'm the Mars director, and I'll tell you what Mars is if you haven't come across it. So the Mars is Membership Accreditation Recognition Scheme. That's what it stands for. And it's a way that we've helped students at Imperial College to think about becoming accredited and getting professional membership with the professional bodies. So we all are aware that you can join the professional bodies and become accredited at different levels at different stages of your career. So what happens on Mars? So on Mars, we get students to join the Royal Societies, and then once they've joined the Royal Societies, they'll join the scheme. And they're supported in thinking about the various competencies and attributes that they are required to demonstrate for things like registered scientist and full membership, as well as thinking about those skills and competencies they need to develop and show evidence of to get chartership. They cannot apply for chartership during their PhD. They have to be employed, but because of the accreditation of the scheme, they can actually start accruing evidence of those competencies during their PhD. How do we help the students? So we have various Q&A sessions throughout the term where students can come along and find out about the scheme. So some of the academics will have chartership, others won't. So they won't necessarily meet people that have charterships or accreditation. So they have these Q&A sessions, they come along, they can ask their questions, they can see a presentation about the scheme. One of the key points of interaction that we have for the students initially is the web pages. And so they can actually go to the web pages and they can find out more information. And it's all sort of linked to there, and we highlight certain elements. The first step, if they're interested, is to become a member of the professional body. So they click on the professional body's website or on the link here, which will take them to it, and become a member. That membership level will obviously depend on the level of their expertise and experience, but we encourage them to join at the highest level that they can. Once they've registered with the Royal Society, they can then actually join the Mars scheme. And at that point, they put details in, such as their supervisor. And the supervisor is invited to be their mentor for the scheme. Now, we like to have mentors that have actually been given chartership or full membership with the Royal Society or chartered biologist. And so if they haven't got a supervisor who's got that level, or for any reason they don't feel able to support and mentor them in achieving the accreditation, then we have a senior mentor who is chartered, who can help support them in that development. So as mentioned, our first step is to get them along, to see what it's about, to find out about it. They're then assigned a mentor, and the senior mentor is also in contact with them at that point. So we have a shared email site so that the mentors know who's joined the scheme. The idea of the scheme in terms of mentoring and supporting the students is that they would meet with their supervisor if they are suitably accredited. They would meet with their supervisor to discuss the Mars scheme and how they might attribute the competencies they need to attribute. Those mentors will then meet periodically with the other mentors and the senior mentors to discuss applications, discuss evidence that people are producing, to try and support each other in recognising what is good evidence, and to look at applications when they get submitted and feedback that we get from those applications. In terms of how is it recorded, once they've signed up to the Mars scheme, they are registered on SharePoint. And so they have an option. They can record their evidence on SharePoint, or they may choose to record their evidence where the facility allows with the professional body. So this scheme was accredited by the Royal Society of Biology in combination with the Institute of Physics. And the Institute of Physics, for example, has a website where they can start recording their evidence there if they so choose. We also have folders, so if they want to be old school and put it in a folder, we've got folders for the Mars scheme as well, so they can keep the evidence there. What we're finding is students and supervisors talk to each other and decide what's the best mechanism to allow access to their evidence to host it. So everything from a Dropbox to the SharePoint. So during their PhD, how do we help them to think about what are the attributes that they need to evidence for registered scientists, membership, and chartered biologist? So these are the attributes that the Royal Society want the researchers to demonstrate to get chartered biologists. And so what we've done for the students is we've taken these, and with the Royal Society, we've taken these attributes and mapped them onto the courses. So we've got about 120 different courses that students can choose to engage with. From those 120 courses, they are classified into sort of different areas, some on communication and presentation, some on team building, so various different skills that they might need to evidence after their PhD, but also evidence for their attributes for chartership. So from the website, they can then either have a look before they join the scheme, or from SharePoint, they get direct access to the mapping that then maps the courses to the attributes. This is a small section of the attributes that have been mapped to some of the courses. So here we see an example of the courses that we provide, or some of the courses we provide in the Research Communication Programme. And so you can see here we've mapped them, and we put them down as whether they're required in terms of mandatory, optional, or recommended. So we have a sort of an indicator to the students. If you want to demonstrate this attribute, do you have the skills required? If you don't, we would recommend or say this course is mandatory in demonstrating those skills. So if you look at the mandatory courses that we provide and we recommend to the students, it would involve taking 20 courses over the period of the 3 years. Within those courses, there are some we recommend during the first year, because these help show those attributes that students need to demonstrate for either registered scientist or full membership of the professional body. If, however, we get a student that says, well, actually, I've got evidence of this, I've done a lot of this already, they have other courses that they could use. In terms of how they use these courses, they are expected to discuss these courses that provide evidence to their supervisor or their mentor of how they've used these courses, what impact they've had on them. So it's not just enough to say, I've done this course. They are expected to reflect on this as well. So they would look at the competency, they would reflect on the courses, they would show that to the supervisor, who would help them review it and discuss actually that sort of difficult step of what evidence does this present for me to demonstrate this competency. So at the MARS meetings, we have mentors meet up, they review the evidence, and they help the students progress through to apply for registered scientists if they would like, to achieve full membership. And they review the evidence collected for the competencies of chartered biologists, so that hopefully by the end of the PhD, when they start working as a postdoc, they have evidence of some of those competencies already in place. Mars mentors, Mars senior mentors, and myself as course Mars director, we meet to review the evidence, and that's actually done for 3 of the professional bodies. So we've got the Mars scheme accredited with the Royal Society of Chemistry, the Royal Society of Biology, and the Institute of Physics. So it's quite a nice sort of group of people to bring together the evidence. And the programme came about initially from roundtable meetings with the Royal Societies, where we identified those attributes that we were able to evidence and by applying. It's annually reviewed. We look at the courses, we look at student feedback in terms of what do they want, what do they need. And we also look for feedback from external as well in terms of competencies that are changing perhaps. So ideally, by the end of the first year, they should have enough evidence to apply for full membership, both from working for a year, from researching for a year, but also from the courses they've attended and the evidence they can demonstrate. They could apply for registered scientists if that's something that interests them, and hopefully they will. And so we encourage them to think about how registration and recognition can help their careers. And by the end of the 3rd year, they should have evidence in place to demonstrate various competencies for chartered biologist or chartered scientist.